All right, well, what would the reaction rate equation be for this reaction? Go ahead and pause the video, put in what you think it would be, and then restart it. Restart it up. Done. All right, so rate equals the rate constant times the reactants, but it's important that those reactants are involved in the rate determining step. And at this point, both of the reactants have always been involved in the rate determining step because we've only talked about SN2 reactions so far. So the rate equation here would be rate equals the concentration of CH3I multiplied by the concentration of OH minus. So that would be, oh, and we forgot our rate constant K. So that would be the rate, essentially now we have to say, well, what happens when we change things? So what happens when we double that, double both of them? So go ahead and try and decide for yourself what happens there. Pause the video now, do that, and then come back. All right, you did that again. All right, if we double that, well, okay, let's say that these concentrations were 1 molar. So it'd be 1 times the rate constant. We'll just say a rate constant was also 1, so rate would equal 1 here. Well, what happens if we double ICH3? That would equal the rate constant times 2 times 1, so that would equal 2. So what happens when we doubled ICH3? Well, the rate doubled. We went from 1 to 2. What happens when we double OH minus? Well, that would be the rate constant times 1, because we're not doubling that and the original concentration was there, times we doubled OH minus, that's 2. So the rate, again, is at 2. So the rate doubled again. What happens with this last one? You have different options on your course booklet, A, B, C, D, E. Make sure you've selected one. But essentially, we would have rate equals K times, we doubled both, so it would be 2 times 2. 2 times 2 equals 4. So 4 would be the rate if K was equal to 1. So what happened? Well, the rate quadrupled. So that's what happens when we change concentrations of our reactants. That should kind of make sense. We already kind of talked a little bit about rate with SN2 reactions, so hopefully this all made sense. Okie dokie. That's kind of the last, no, it's not the last piece. More coming about SN2 reactions.